Karamoğlu will present us a topic which is Aloe Vera-based green and sustainable electrolyte for zinc ion batteries. So if you are ready, Gökçe, you can start.
I'm ready. As Musab said, I'm Gökçe. I'm going to make a presentation about sustainable electrolytes, and this study is based on aloe vera, and this study is made by Recep Yüksel and published in Advanced Sustainable Systems. And as the world requires more energy day by day, we need more sustainable, safe, and suitable to application energy storage systems. There are lots of lithium-ion batteries in the market now, and there are some problems with the sustainability, safety, and application with lithium-ion. And briefly, they cost highly, and they are using scarce materials, and it has toxic organic electrolytes in them. And even if it has excellent density, but it's limited for safety in the grid scale storage. In the next generation energy storage systems, we must use abundant, low-cost materials and non-flammable and eco-friendly systems, and it must be safe for customer electronics, electronic vehicles, and large-scale power grids. And there is a great example for this batteries, for a battery system, and this is zinc ion. And a zinc ion battery has a zinc anode and a cathode that can host zinc ions, and a zinc containing electrolyte to shuttle the ions between them. And zinc ion has great advantages in economic sustainability, compact design potential, and safety, environmental integrity, also electrochemical advantage, which can be used in aqueous electrolytes, which can be used in zinc ion batteries. As we mentioned the advantages, there are also disadvantages, but the researchers are working really hard for the development and for in this disadvantages. So about the challenges in the zinc anode, there is zinc dendrite formation, also hydrogen evolution reaction and corrosion. But with the modification in electrolyte or separator or anode surface, there can be, improvement with these problems. And in this study, they focused on electrolyte development, electrolyte, based system. And we see in this aqueous electrolytes, there are liquid, gel, and multifunctional electrolytes, but we are focusing on green and biodegradable electrolytes in this study. And why did they use aloe vera? This material, this plant, has a rich natural chemistry, and quinone and polysaccharide presence in this mucilage, in this gel, is expected to stabilize zinc anode in two ways. By controlling zinc deposition to prevent the growth of dendrites, and also the aloe vera is interacting with the water molecules. So the parasitic hydrogen evolution reaction and corrosion is, being reduced. And how did they make the electrolyte? They peeled the skin of the aloe vera and used the flesh and gel and mix them together, and by last add zinc sulfate salt. So firstly, before going to before the performance tests, we should see what is in this aloe vera. So the composition of aloe vera, and they made FDR spectrum tests, and as I mentioned earlier, we can understand it has quinone and polysaccharides in it. Also, by the Raman spectra, the comparison with aqueous electrolyte, they saw that the electrolyte inhibits the free water molecule and enhances the stability. As I mentioned earlier, it is a must obtain, must obtain specific. I'm sorry. With the holding of the free water molecules, it reduces the hydrogen evolution reaction. And in this contact angle measurement, we see that the angle is reduced with aloe vera. This means that aloe vera's wettability is much greater than the aqueous electrolytes. And in this last picture, we see the microscopy image of 1 hour cycle of zinc anode in aloe vera based electrolyte and aqueous electrolyte. The zinc formation is much more regular in the aloe vera. And electrochemical stability test, they made various tests in this field, and in different current densities. The most successful test of them all is with 2 milliampere per centimeter square, and this in this test we see that aloe vera cycled more than 4,500 hours, which is showing a great stability. And also at the last picture, we see its behavior in the different density of current. And in this first picture, they went to SEM and got aqueous electrolytes and AV-based electrolytes behavior in a picture. In this first picture, we see that dendrite formation happened, and in the right picture, we see that it is much less. It is suppressed with aloe vera-based electrolyte, and with LSV, linear sweep voltammetry, they see that the hydrogen revolution potential was significantly decreased with aloe vera, and with TEFL, the hydrogen evolution reaction and anode corrosion is decreased with aloe vera. And with the last picture, we see that schematic for what I was telling. The zinc anode in zinc ion batteries, the dendrites happens to be hexagonal, and as you see in the schematic, and they can also create spikes by piling up, and the right we see aloe vera based electrolytes, and it is more regular and more, um, more regular than the aqueous one. And at the last, for realization of this electrolyte, they made test with vanadium dioxide cathodes. And in this first picture, we see the lower charge transfer resistance in aloe vera than water, aqueous electrolytes. And the CV plot is typical plot for vanadium dioxide. And the last picture, we see the comparison between aloe vera and water, and the you know the reduction of the efficiency, and it is much better in aloe vera. Thank you for listening. If you have any questions, I can answer gladly.
Thank you so much, Gökçe. Guys, is there any question you need to ask? So maybe I can ask a quick question.
Okay.
I think I missed that part. Could you please explain the experimental method you applied when you are making electrolytes? I just missed that part.
So
Yeah.
you can see, right?
Yes.
The experimental part is, getting the gel part of the aloe vera and mixing it with, um, mixing it with zinc sulfate salt for 2 molar, solution. And we are using it on a Swedge-Lock cells, which is, if you know, containing of 2 steel, attachments, and we are making symmetrical, cell, zinc separator and electrolyte, also zinc. This is the experimental method, I can say.
Okay, thank you.
You're welcome. Any other question?
So I think there.
I have a
Yeah.
I have a question.
Okay.
Thank you for your presentation, Gökçe. I'm wondering that how do you get the idea of using aloe vera as an electrolyte? And why
First,
didn't you choose another material instead of using this? Just I'm curious about the idea of aloe vera. Thank you for your presentation.
you're welcome. Thank you. Firstly, this isn't my study. This is my supervisor's study. But as I said, the components on the aloe vera gel is, containing hydroxy and carboxyl, you know, attachments in the organic structure, which they can, attach water molecules to them, which is great for hydrogen evolution reaction reduction. So, and it's you know, this is a study in the gel electrolytes, and they are, in the search of structures like that for, you know, um, decreasing the hydrogen evolution. I can say that, but there can be lots of other studies, um, searching for other natural gels,
I understand. Thank you.
You're welcome. Is there any other question?
So if there is not, we can end up our weekly meeting. So for those who is watching until here, we can conclude with by saying that if you are interested in battery technology, electrochemical storage, you can join our team. We have weekly seminars and gathering around from all over the world, and we want to explore more and more energy storage systems and increase our network. So thank you for all of you guys listening, and thank you Gökçe for your great presentation.
Welcome.
I wish you the best luck. So guys, see you on the next week.
You.